we're discussing about of a problems. So which of the electrostatic potential and capacitance. Now we're discussing about the problems on electric potential. Exercise 2, question number 1. Two parallel plates are 0.03 meters apart. The electric field intensity between them is 3000 Newton per Coulomb. Calculate the potential difference between the plates. See, this is given by the two parallel plates. This is the two parallel plates. The separated by distance, the D is equal is given 0.03 meter, and electric field between E is equal is given. This is the electric field is the between the these two plates. This is given by the 3000 Newton per Coulomb. Newton per Coulomb. What is the potential difference between the plate? See, this is the positive charge. This consider the negative charge. Now, what is the formula for the electric potential? E is equal to the relation between E is equal to V is equal to E by D. Then, sorry, here the writer E is equal to V by D. Then the V is equal to E into D. Then write the E is equal to, how much is there here? The 3000 into D is there 0.03. Then the calculation we are getting by the 90 Coulomb, 90 volts. This is the electric field between the two plates. Let's see the question number 2. Two electric charges 9 Coulomb and minus 3 Coulomb. See, here is given by the first charge is given by the 9 Coulomb. See, another charge is given by the minus 3 coulombs. Are separated by distance is given by the 0.16 meter. How much of the distance is there here? 0.16 meter in air. There will be the point at which the electric potential 0 on the line joining of the two charges between them. See, here the point. For example, this consider the charge. The positive charge is placed at the A point and negative charge is placed at the B point. See, electric potential is 0 at the line joining of the midpoint of the two charges. That is considered a P point. P point. Then the distance P from the 9 coulombs. See, this is the how much of the distance will be there. Now distance we can find out. This is considered the X. The remaining is considered the 0.16 minus of X, because of here is given by the total charge. But here is there the one positive charge and one is the one negative charge. See, that time the electric, the null points, that is the formula X is equal to D by Q2 by Q1, Q2 by Q1 plus 1. So write here the value. D is equal to how much is given? 0.16 by Q2. Q2 is equal to is given 3 by Q1 is the 9 plus 1. Here how many times are there? 3 times. So then the calculation here the 0.16 by cross 1 plus 3 by 3, that is equal to 0.16 into 3 by 4. Now here how many times are there here? The 0.4 times. Okay, into 3, that is equal to 0.12 meter. How much is there? 0.12 meter is the distance from the X to point P. See the question number 3. The charges 5 microcoulomb, minus 2 microcoulomb, 3 microcoulomb and minus 9 microcoulomb are placed at the corner A, B, C, D of a square, the side of 1 meter. The net electric potential of the center of the square is, now this is considered the square. It is placed on A point, B point, C point and D point. Here is charge Q1 is equal to is given 5 microcoulomb. Now the Q2 is equal to is given minus 2 microcoulomb and the Q3 is equal to given 3 microcoulomb and D, the Q4 is equal to given minus 9 microcoulomb. Now each side is given by the 1 meter. Each side is given by the 1 meter. So this is the 1 meter. Now we can find out the center. Center means here the center. Now the center we can show the O, the A to O distance or O to B distance or O to C distance and O to D distance. The both are will be same. Now here this is the distance from the center to O. A point. See, this is the side, this is also side. Apply the Pythagoras rule. Side square plus side square is equal to hypotenuse square. Means 1 whole square plus 1 whole square is equal to hypotenuse. That is equal to root 2. Root 2 means the half of is there. This value is there. 1 by root 2. How much of the value is there? 1 by root 2. We can find out the net electric potential at the center of a square. The net electric potential. See, what is the formula for the net electric potential? We know the V net, the electric potential net is equal to 1 by 4 pi epsilon naught Q net by R. Q net by R. Then we can write here the values are. This is the constant value 1 by 4 pi epsilon. What is it? 9 into 10 power of 9. And Q net is equal to Q1 plus Q2 plus Q3 plus Q4. This is the all charge of the adding by R. R is equal to nothing but to point to center. This is a 1 by root 2. Then here write the values are. See what we can write here the values are there. The Q1 is equal to how much is there here the 5 microcoulomb. That is equal to 9 into 10 power of 9. 9 into 10 power of 9 into, see, all will be there, the microcoulomb, take the common, 5 minus 2 plus 3 minus 9 into 10 power of minus 6. See, 1 by root 2. Now the calculation we are getting by this is the values minus 27 root 2 into 10 power of 3 plus 3 into volt. See, that is equal also 10 power of 3 we can write the kilo volt. See, this is the V net potential of this square. Let's see the question.